Hello, class. This is the first video covering activity 3.3 from our text. The objectives are to determine the decay factor for an exponential function represented by a table. We're going to graph an exponential function, and we're going to determine the halving time, sometimes referred to as half-life. So we start out with an example. We've just purchased a car for $22,000. And you've learned that the car depreciates in value by 30% each year, right? So this word depreciate basically means loses value or will go down in value. So most cars lose value as they age. Every now and again, you'll see a car owned by Jay Leno or Jerry Seinfeld, some weird Ferrari or Rolls Royce that appreciates in value, but the majority of cars depreciate or lose value. And this particular car loses 30% of its value every year. So here's a table that will give you the value of the car for every age of the car, right? So when the car is 0 years old or brand new, it's worth $22,000. The 1-year-old car is worth $15,400, and a car that was 4 years of age has a value of $5,300, right? So you can see the older the car, the less value the car has. Okay, so question 1. It says, as the input increases from 0 to 1, the output decreases from 22 to 15.4. What do you multiply 22 by to get this 15.4? Well, the easiest way to figure that out would be to actually divide. Right? So if I were to divide the 15.4 and the 22, you see I end up with 0.7. So let's put that in for letter 1a. We're going to enter the value of 0.7. All right, so here's my 15.4 divided by 22. I end up with 0.7. Now, part B says, use the information in the preceding table to write an equation in the form of v equals ab to the t. Now, notice this is very similar to one of our objectives. Right? The objective is y equals ab to the x. But they've substituted the value y and v, right? So instead of y, they used v for value of the car. Instead of x, they used t for time or the age of the car, okay? So remember, a always represents the initial value, right? So in y equals ab to the x, the a is the initial value. So what's the initial value of the car? 22, right? In thousands, 22,000. So we know what the letter a is. B is our growth or decay factor, right? And that was found by dividing successive outputs, right? So the successive ratio was 0.7, right? If I did 15.4 divided by 22, I ended up with 0.7. So my B is this 0.7. My A is the initial value, which is the 22. So we can write the equation here. So after I substitute the 22 in for A and the 0.7 in for B, here's my exponential function. Question 1c says, all right, let's input this into our y1 on our graphing calculator. So I press y equals. I'm going to clear, I had some previous work up here, so I want to clear everything out. Again, make sure my plot 1 and plot 2 are not highlighted. Right, if you were doing some linear regression, you might have a box up here. You want to make sure that your calculator does not look like that. Let me turn that off. Okay, so I put in 22. Here's my 0.7, and that's raised to the, we'll use the letter x since our calculator doesn't have t. And I'm going to graph this on a 10 by 10 window. Right, so right now my window is, you see I have 150 and 225. So I could either manually enter -10 and +10, but a quick way to do that would be just press the zoom key, and number 6 for standard will give me a window that has 10 tick marks in every direction, meaning I can count from 0 to 10 to the right, 0 to -10 to the left, 0 to 10 going up, and 0 to -10 going down. And when I press window, you'll see it actually populates -10 to 10, right? That's considered a standard window, okay? So, you know, the book's basically asking you to just sketch that graph and write that in that blank box. on your paper, okay? So that's what my graph looks like. Part D, it says determine the value of the vertical intercept of the graph. Well, remember, the vertical intercept happens when you substitute in 0 for the input and solve for the output. So in this case, if I were to substitute 0 in for t, I'd have 22 times 0.7 raised to the 0. And we know anything raised to the 0 is 1, so you'd really be left with 22 times 1. All right, so the vertical intercept should be 0, 22, and then we'll take a further exploration of this concept. All right. All right, so there's my ordered pair 0, 22. If I take my graphing calculator, if you press the trace key, notice on the bottom it says x equals 0. So basically we're saying to the calculator, when x equals 0, what does y equal? And you get 22. Okay. If you want to see where does this cross the y-axis, it's going to happen at 0, 22. Let's change our window. And for y max, I'm going to make that 30. Okay. Now press graph. You see this dot here? This at 0, 22. That's where the function crosses the y-axis, which is also known as the vertical intercept, right? So the vertical intercept is the point on the graph that crosses the y-axis, and that point is 0, 22. All right, and again, the other way to find the vertical intercept would be substituting 0 for the input, solve for the output. The input in this case is t, and the output is v. So 0.7 raised to the 0 is 1. 1 times 22 is 22. All right, so when t is 0, v is 22. Part E, the practical meaning, and that's very important for this class, right? We don't want you to just plug in numbers. We want to know what do these numbers actually mean. So in this case, the practical meaning is the initial value of the car is $22,000, right? The starting value of the car is $22,000. Right, so there's my practical meaning. Okay, I think we're going to stop here and look for part 2 of activity 3.3 in Canvas.